Hi, in this video I'll demonstrate how to do electricity investigation 1. So first log in to manage back, go to the tasks and look at electricity investigation 1 instructions. As you can see, I have attached so many files here, so download all of them first to your computer and start by looking at the list of PHET electricity experiments spreadsheet. So that spreadsheet is here. So you have to start with the first experiment and one by one move on to all the 8 experiments. Now I have designed these 8 experiments to cover the electricity chapter completely from all angles, right? So it will be best if you do all of them. So let's see what you're supposed to do in the first experiment. The first experiment, the inquiry question which you are investigating is, how does the current through a particular resistance vary when the potential difference across it is varied? So let's see what kind of circuit diagram we need. So for that you would have downloaded the circuit diagram file. The attachment is given here. See, this is the file, circuit diagrams for PHET experiments by Gyani. So click on that Word document and download it. So the first experiment circuit diagram is numbered here as 1. For experiment 2 you have to use the second diagram and so on. For experiment 3 you have to use this circuit diagram and so on. So if you look at the circuit diagram, you find that there is a battery, a resistance, an ammeter to measure the current which is flowing through this resistance, and a key to either turn on or off the circuit. So if I pull this key out, the current will stop flowing. If I close the key, the current will continue to flow. So we want to see how the potential difference across this particular resistance varies. If you change, what are you going to change? No, you are going to find out how does the current through that particular resistance vary when you change the potential difference across it. So you will be plotting a graph of current versus voltage, and you would verify the value of the resistance which you used for your simulation. So the initial conditions should be different for each student. So pick any random value of resistance for your experiment and note it down in the spreadsheet before you start the experiment. And then when you complete the experiment and plot the graph, from the graph you should calculate the resistance value, and it should match with the value which you used for your experiment. So you will be calculating the resistance from the slope of the graph. So that's how you verify Ohm's law, from the nature of the graph. So see, here I have mentioned the steps also how you should do. First you have to set up the circuit 1 in PHET as shown in the circuit diagram. So let's do step by step as it's given here. So open the circuit diagram, make it appear in half of your screen. Then go to that PHET simulation. So how do you go to the PHET simulation? Okay, have I given a link to it? Okay, so here I don't seem to have given the link. Anyway, by now you should know how to go to PHET simulation. Just click on go to a new browser and type PHET in the search bar. You will get this very first link. Click on it. And many of you have faced difficulties in installing it. So this is how you have to click on full installation and then follow the instructions and install it. Okay, it's self-explanatory. Now to open the simulation for our experiment, go to play with sims, then go to physics, then go to electricity, and then click on circuit construction kit and run. Okay, now I have already installed it, so I have already opened it, so we'll go to the simulation here directly. Okay, so from this panel we have to grab the components and create this circuit. It's simulating how you would set up a circuit in the lab. So once you get the hang of doing the experiment and plotting the graph, I'll take you to the lab. Okay, so first let's put the important part, which is the battery. And then I want to connect it to a resistor. Then I want to measure the current using an ammeter. So click on this checkbox, the ammeter will appear. So you connect it in series. So remember, ammeter is always connected in series with the in the circuit, because it has to measure the current flowing through the circuit. In order to make the circuit diagram look neat, I am using so many wires. Okay, then I'll add the switch or key. Right now it is open, as it should be. Even when you come to the lab, initially keep the switch open. Only after you finish connecting everything and you are ready to note down the measurements, you should close the key. That's it, the last wire. Yes, now the circuit diagram is completed as given in the document. So now close the key and you can see that the current is flowing. So now you have to assign some initial value of the resistance. So right click on the resistance, make it show the value. Right click on the battery, make it show the value. So right now the initial value is 10 ohms. So I said each one of you should use some different value of ohms. So let me change the resistance. Let me make it some different value. Let me make it 5 point, or let me make it 4 ohms. So again make it show. Okay, it became 2.94. Change value 4, press tab. So after typing the new value, press the tab key in your keyboard, so then it will register the new value. Now click on done. Now when you click on show, it is showing 4 ohms. So enter that in your observation table in the spreadsheet. So for experiment 1 I have created the raw data table here. So here make the resistance 4 ohms. If in the file which I uploaded, I think here I did not write resistance, I wrote voltage, I think, by mistake. So correct it to resistance and write the initial value of resistance which you used in your experiment as 4 ohms. Now to type this symbol omega, which is a symbol for resistance ohms, what you need to do is click on insert menu, go to symbol and select it from the list. If it's not appearing in the recently used symbols, you have to select in the font normal text and then in the subset mathematical characters, and you will find it. Okay. Okay. So now if I have already put some default values, I can remove it. So potential difference would be the independent variable which I am changing, and current is the dependent variable which I will be measuring. So make it part of the screen. Okay. So I have decided to increase the voltage by 1 unit and measure it 10 times. So for the corresponding values of voltage, I will now measure the current values. So first start with 0 volts. So right click on the battery, change voltage and type 0 and press the tab key, then done. So it shows 0 ampere current. So type that, record it in your observation table. Now make it 1. Press tab again, click done. Now it shows 0.25 amperes, so note it down. Now change it to 2 volts. Tab, done. Now it shows 4 ohms. Oh sorry, current is 0.50 amperes. Now change it to 3 volts. So it's 0.75 amperes. Now here, since we are doing the experiment on a simulation, all the values are exactly perfect, like as you expect, right? I is equal to V by R. So whatever is the V value, if you divide it by the R value, you will get this. So you'll be tempted to note down the values for the remaining without doing the actual measurement. Don't do that. I want you to get the practice for doing this experiment, so do it each time by changing the voltage of the battery and measuring it in the ammeter. When you go to the lab, you would find that you won't get such exact values. They will be fluctuating either up or down from the expected value, either more or less than the expected value. That's natural. So that's how reality is different from a simulation. Okay, so so I finally changed the voltage all the way till 9 volts and saw that the current was 2.25 amperes, so I've noted it down. So this completes the collection of raw data for your experiment. Now you need to process this data. So let us see what I have given in the instructions. Go back to the list of experiments. So first is set up circuit 1 as in PHET as shown in circuit diagram, which we have done. Then I have asked you to vary the voltage of the cell and note down the current value shown by the ammeter. Thus record the data in the observation table. This also I have done. Next I have asked you to plot a graph of current on the y-axis. So current is the dependent variable, plot it on the y-axis, and voltage across resistance, which is also the voltage across the cell in this case, on the x-axis. So let's do that. Let's plot the graph. So the dependent variable should always be on the second column and the independent variable on the first column. Okay, what did I give in the instructions? Current on the y-axis, voltage on the x-axis. Did I say that? Yes, current on y-axis, okay. So you need to first select the cells containing the x and y values, that is the independent and dependent variable values. Then go to the insert menu, click on scatter, select the graph with all the dots, the scatter with only markers. So the spreadsheet will give you the graph. Then you have to immediately put the chart title and the axis titles. So click on layout. This layout is under chart tools, and then go to chart title, select above chart, and the title should be of the form dependent variable versus independent variable. So dependent variable is current here, so current versus potential difference across the resistor. So in this particular experiment, see, my goal is actually to find how the current and potential difference across the resistor vary with each other. So though here I have written potential difference across the cell, it actually means potential difference across the resistor, because in this particular circuit diagram I have only one resistor So the potential difference across the cell is completely dropped across this single register. So it's the same value. Anyway, since my goal is potential difference across the register, I will change it to that. Okay. Next, again click on the graph, go to chart tools, layout, axis titles, primary horizontal axis, title below axis. So here you have to type the axis title according as shown. The horizontal, the independent variable name, followed by the symbol, followed by slash, followed by the unit of that quantity. So we have to type potential difference across resistor, comma, V space slash space, again the symbol for the unit, which is again volts in this case, so which is again V. Then again go to axis titles, primary vertical axis title. Now select rotated title. So the rotated title would be, so directly start typing, it will start appearing in this bar. So current comma I space forward slash, the symbol for current is A, symbol for the unit of the current is A, symbol for current is I. Press enter and the current will appear here. Now you need to connect the points to form a graph. Now by looking at the position of the data points, you can see that you should get a linear graph, which is a straight line graph, and it should pass through the origin. So now click on, under layout you will see trend line. So go to more trend line options. It's automatically selected as linear, which is what you need in this case. So select the linear graph. If your data points are scattered in such a way that you get some kind of curve, you can select polynomial. So in this case we will select linear and select the checkbox for display equation on chart and display R squared value on chart. Now R squared value can only range between 0 and 1. The closer it is to 1, it means the graph which the spreadsheet is plotting for you is accurately fitting the data. So if it's exactly 1, it means the graph which the software is plotting is a perfect fit for your data. If it is less than 0.9, then it's not such a good fit. So for your experiment, you need always the graph plotted by the software to be as good a fit as possible for your data. So the R squared value should always be more than 0.9. Okay. Now this backward and forward, this is used for extrapolating the graph to cover a bit more on the x-axis. For example, your data points do not have 0 in them, then your graph would start from x coordinate 1 only. But you want to check whether your graph passes through the origin. So then in backward you can type 1 unit. That is, you want the graph to extrapolate or extend backwards by 1 unit in the x-axis. So then you can force it to pass through the origin. So in our case, since the data point itself is having 0, so we don't need to do this. So in future you can also plan your observation table in such a way that you always have you collect the data for the 0 value of the independent variable. Then you don't need to use this backward feature to make the graph extrapolate. But in certain experiments when you can't do that, then you can use this to extrapolate. Okay, now click on close. So you can see the straight line graph. Click on this equation and move it to this white space so that you can read it clearly. So now you can see that the equation for this straight line is y is equal to mx plus c. So m corresponds to the slope of the graph and c corresponds to the intercept. So let me write it down for you here. So equation for straight line is y equals mx plus c, where m represents the slope of the graph and c represents the y-intercept. So y-intercept means the point where you expect the straight line graph to cut the y-axis, and m tells you how much it is inclined. So if m is positive, the inclination should be like this. If m is negative, the inclination should be like this. If m is 0, it should be horizontal. Okay, and whatever is the c value, through that point on the y-axis the straight line will pass. For example, if this is your graph, this is y and this is x, if c is 2, then the straight line graph will pass through y. If c is 2 and m is say 1, the straight line graph would pass like this at a 45-degree angle through 2. Clear? So if you compare it with the equation given by the spreadsheet, it says y is equal to 0.25x. So y equals 0.25x. So that means if you compare the corresponding coefficients of x, you get that 0.25 should be the value of the slope. So m is equal to the slope of this graph, which is equal to 0.25 units. Now what should slope represent? So from Ohm's law, you know that if you draw this visual way of representing the Ohm's law equation, if you want to find current, it is V by R. If you want to find resistance, it's V by I. If you want to find the voltage or potential difference across the resistance, it's IR. V is equal to IR. So here, what is the dependent variable? The dependent variable is the current. So you need to find I. So I equals V by R, which can be written as 1 by R times V. So here we have kept the resistance constant throughout the experiment. So 1 by R is our constant or slope, and V is the independent variable, and I is the I is the dependent variable, because the value of I depends on what value of y you are taking for your experiment. So that's why I is plotted on the y-axis and V is plotted on the x-axis. So the slope represents 1 by R, so you can equate it to 1 by R. So from that you can calculate what should be the resistance. Now since the current was taken in amperes and voltage or potential difference was taken in volts, so the unit of the slope would be, it's a change in, slope of a graph is change in whatever you are plotting on y-axis divided by change in whatever you are plotting on x-axis. So the units would be unit of whatever quantity is on y-axis, which is amperes, divided by whatever is the quantity in x-axis, which is volts. So it's basically current by voltage. Right? And you know that current by voltage is 1 by R, So it would be 1 by ohms, or you can write it as per ohm. So from that you get that, and since current is in amperes and voltage is in volts, the answer of this slope should also be in SI units. So that should also have the unit in SI, which is ohms. So resistance would get the unit of ohms automatically. So R is equal to 1 by 0.25, so which is 100 by 25, which is 4 ohms. So that's what you used in your experiment also. You recorded it here. So resistance is 4 ohms. So since we used a simulation, it's exactly matching. The slope is exactly matching whatever is the correct true value. But in real life, when you do it with actual ammeters and resistors and batteries, you would find some variation. Okay. So now this is the result. So this is what you have to report in your investigation report. So in the conclusion, you have to write that from the slope, the resistance was found to be 4 ohms, which is indeed the actual value used in the experiment. Thus, by calculating the slope from the graph of current versus voltage, I verified Ohm's law. So you have to show all these calculations in the investigation report.